Last thing we're going to look at here is word problems involving proportions. Number 6 tells us a local newspaper claims that 10% of Philadelphia residents still read the newspaper every day. A random sample of 120 Philly residents is taken. What's the probability less than 8% read the paper every day? In this case, we know it comes from a population where 10% read the paper every day. We're going to look at 120 people, and we're looking for the sample value to be less than 8%. Probably the trickiest part of this that confuses students is remembering that 8% isn't 0.8, but it's 0.08. Otherwise, I can set up this z-score as z equals the p hat that I'm studying, 0.08, minus mu sub p hat, which is just the p from the population, 0.10, over the root of the p from the population, 0.10, times 1 minus the p from the population, 0.10, over n of 120. When I put this into my calculator, I put it in as parentheses, 0.08 minus 0.1 and parentheses divided by the root of parentheses, 0.10 and parentheses, new parentheses, 1 minus 0.10 and parentheses divided by 120 and parentheses to make sure it's still all under the root. That should give me negative 0.73. Now that I have a z-score, I go to my table, I look up on the negative side, negative 0.7 is my row, I go over to the column, 0.03, and I get a p-value of 0.2327. Because this is a less than question, I can stop right there and say that's the probability that less than 8% in the sample read the paper. For question 7, it says the Philadelphia Eagles claim that 20% of fans who attend their games are under the age of 18. So that tells me the p that they're looking for is for 20%, 0.20 or just 0.2. A random sample of 200 fans, that's my n. I looked at 200 of the fans at a recent game was surveyed. What's the probability that more than 17% are under 18? So that means in the sample, we're looking for to be 17% or 0.17. Again, this is an example where the question does have another number in there that's a distractor. This, whether they're under the age of 18, is important to the question, but the 18 itself isn't a number I'm going to use in my calculations. So here, when I set up my z-score, it's going to be based on that 0.17 from the sample, minus 0.2 for the population. The square root at the bottom uses the population value of 0.2, and it uses the n of 200 that were in the survey. When I put this into my calculator, parentheses, 0.17 minus 0.2 in parentheses divided by the root of new parentheses, 0.2 and parentheses, new parentheses, 1 minus 0.2 and parentheses, divided by 200. All of that gives me negative 0.07. So I'm going to take that negative 0.07, look it up in my chart. 0.0 are the first two digits. I go over to the column mark 7, and I get a p-value of p equals 0.5279. So with that 0.5279, I then want to find the more than. So what's the probability that more than 17%? Something definitely went wrong here. Let me double check my calculation there. I do this, 1 minus 0.2. There's what happened. I was missing a parentheses. Apologies, these are not the correct numbers. So as I was looking at it, it didn't look right. Really, if we have 17% who are under 18, it should be less likely than what we were coming up with. So this looks more correct. When I put the correct parentheses in, I get negative 1.06. That, when I look up the probability on the negative side, 1.06, I get a p-value of p equals 0.1446. So the probability that we get more than that would be 1 minus 0.1446, which would give me a final answer of 0.8554. Sorry about that quick mistake, but pays to check, double check, make sure everything that's happening under the root is all put in properly and happening under the root.